Hello everyone. So this is the last lesson for our Math 1342 series. So we're going to be going over chapter 9, which is over hypothesis testing with one sample. And we will also be going over chapter 13, which is over simple linear regression. So if you want a clear overview of hypothesis testing, I would encourage you to go to this YouTube video that kind of gives you a brief overview that kind of gives you this grand idea of hypothesis testing, which our lecture today is going to give you kind of more like the nuts and bolts instead of a grand overview. So there are three methods for hypothesis testing. There's the critical value method, which is the traditional method. There's confidence interval method, which is based off of using confidence intervals that we did last time. And then there's the p-value method. You can use any of these methods. The textbook teaches all of these methods, but we will be using the p-value method. So hypothesis testing can be broken down into 4 steps. You want to first write your hypothesis. You're going to have 2 hypotheses that you write. You're going to write your null hypothesis, which the notation for null hypothesis is here. It will always have your variable equal to a hypothesis. Then you're going to have your alternative hypothesis, which the notation is here. It can also be written as sub A. You'll see some notations have sub A. And that is written as either less than, greater than, or equal to. So then you're going to, the next step is determine the type of hypothesis test you're doing. There are 3 types. You're doing either left-tailed, right-tailed, or two-tailed. That comes directly from your alternative hypothesis. If you're doing left-tailed, you had a less than sign in your alternative hypothesis. If you're doing a right-tailed, you had a greater than sign in your alternative hypothesis. And if you're doing two-tailed, you had a not equal to sign in your alternative hypothesis. Then you're going to choose the correct distribution, which will either be Z, which is the normal distribution we've talked about, or T, which is the student T distribution we learned about last class. Use the corresponding Excel code to find the test statistic and p-value, which we will look at together shortly. And then you're going to make a decision about whether you reject or fail to reject your conclusion based off of what you see in step 3. And we'll go about that in a little more in depth in a moment. So, null hypothesis versus alternative hypothesis. I briefly described it before. This is a written statement of the difference between the two. I encourage you to pause this and read. All right, so here we have some examples of the null and alternative hypothesis. And it's a really important step. Step 1 is determining how you write your hypotheses. And writing your hypotheses will determine every other step from here on out. So we need to practice this. So let's take a look here. The claim is that the mean annual income of employees who took a statistics course is greater than $60,000. So your null hypothesis is easy. It's always the same. It is the symbol. We're using mean, so we're going to use mu here, is equal to, it's always equal to, whatever value you're looking at, so 60,000. Your alternative hypothesis is determined by the statement here. So this is mu is greater than 60,000 for all alternative hypotheses. So for the claim that the proportion of people age 18 to 25 who currently use illicit drugs is equal to 20%, we would say, okay, well, our null hypothesis, this time we're talking about proportion, so we're using P, is equal to 0.2 for the decimal form of a percent. And our alternative hypothesis says is equal to. Well, we're going to do the opposite of that because we already took up the equal sign in the null hypothesis. So we're going to say not equal to when we're testing this. So it feels backwards because you're doing the opposite, whereas here you did exactly like it said. Okay. That only happens for equal. If it says equal, you're always going to do not equal to. The claim is that the mean weight of plastic discarded by household in 1 week is less than 1 kilogram. So again, your null hypothesis is your symbol. We're talking about mean, so we're using mu is equal to whatever value. We're given 1 kilogram. So I'm just going to use 1 here. So alternatively, we're doing the mean is, and you're going to the statement, less than. So less than 1. So I am going to give you a minute to try these 3. And then after you have tried these 3, you can check the annotated notes on Blackboard to make sure that you did these correctly. It's important that you do these correctly because, again, it will determine everything from here on out for the rest of the problems. So please pause and try these and then check your annotated notes. All right, so step 2 is, again, deciding between left-tailed, right-tailed, and two-tailed. And this always comes from your alternative hypothesis. Remember, if your alternative hypothesis has less than, you're using a left-tailed. Greater than, you're using a right-tailed. Not equal to, you're using a two-tailed. So pretty straightforward, that step. But again, you can see why determining your hypothesis correctly is very important because it will determine what kind of test you're doing. So this is a pictorial representation of what that test means if we were looking at it as far as left-tailed, right-tailed, and two-tailed. So we're saying the probability that alpha is less than, we're looking in the left-tailed, greater than, right-tailed, not equal to, two-tailed. So then step 3 is choosing the distribution. The distribution is really clear. If it's a proportion, you're going to be doing a 1-prop z-test because you're using the z-distribution or the normal distribution. If it is sigma that is known, so population standard deviation is known, you're going to do a z-test because you're using the normal distribution. And if the population standard deviation is not known, you're going to be using a t-test because the student t is what is most appropriate. So in this case, I want you to realize that the distribution we're using is the same distributions we were using in confidence intervals for the same rules, essentially. So let's go ahead and take a look at the next one. So the basic idea is that the farther out in the tails of the distribution that the test statistic value is, the more we want to reject the null hypothesis. So that's the whole idea here. If it's falling in those tails, we want to reject it. So we reject the null hypothesis if the p-value is less than or equal to alpha. So that is the rule that you're using in step 3 to make a determination. And then your test statistic is the value that's produced in Excel that you're comparing to alpha. So we'll take a look at that in just a second. So again, this summarizes when you use which test. And for your convenience, I labeled those in Excel. So you see on your midterm 2 Excel program, you will see that you have these 3 labels as 3 possible sheets to work off of. And that is how you will use, know which sheet to use. So this goes over significance level, which is alpha, and that comes directly from confidence intervals. They're related there. And so we can find alpha based off of confidence levels if we need to, or alpha can be explicitly stated. So this reiterates that we're going to reject the null hypothesis if the p-value is less than or equal to alpha. And we're going to fail to reject the null hypothesis if the p-value is greater than alpha. And this is important. We don't accept anything, or we don't prove anything when we do hypothesis testing. We are either rejecting or fail to reject. And so that language is really important. So this tells you the condition and how you're going to state your conclusion, because like I said on the previous slide, how you state things is really important when it comes to hypothesis testing, because again, we can't prove anything, we can't accept anything, we're either rejecting or failing to reject. And so we can either support or not warrant support. So the way we state things is important. So you can use this to refer to figure out how to state things. So we have some fully worked examples that go through step by step. You do have these available to you for you to view on the annotated notes and the blank notes. So I encourage you to go walk through each of these. The reason I gave you 6 completed in the slides is because the ones I'm going to do in Excel are going to be different from the ones you did in the slides, just so you see several different hypothesis tests. So I encourage you to read through these examples. You can pause on each one of these if you would like, or you can just refer to the notes. And you can see the summary of how we do things. So this shows the conclusion statement based off of the conditions that you found. And you can do this for every single problem. So we're going to pause there on the notes, and we're going to switch over to Excel to work through some example hypotheses. So give me just 1 second to share my screen. So this is the midterm 2 Excel program. This is what I was talking about. If you're doing a Z-test for hypothesis testing, you're using this sheet. A t-test, you're using this sheet. A 1-prob z-test, you're using this sheet. Because we're doing examples together, I'm going to use this other sheet, which is also provided to you on Blackboard, because I have the examples already written in here for you. So the health of employees is monitored by periodically weighing them in a sample of 54 employees. Has a mean weight of 183.9 pounds. Assume that the population standard deviation is known to be 45 pounds. Use a 0.10 significant level to test the claim that the population mean of all such employees' weight is less than 200 pounds. So again, you're just filling in the green, and then you're going to get some outputs given to you. So our sample size here was 54 employees. Our sample mean was 183.9. Our population standard deviation was given to be 45 pounds. And our hypothesis mean comes from this statement is less than. So we're doing 200 here. And so we get a test statistic here. This is the test statistic you're using. And then based off of how you state your hypotheses will be whether you choose left-tailed, right-tailed, or two-tailed. So our first step on these was to identify what is happening here. So here in the hypothesis test, we know the null hypothesis here is that the mean is equal to 200. The alternative hypothesis is being stated explicitly, less than 200. So the mean is less than 200. So in step 2, we see a less than sign here. So this means we're doing left-tailed. And that's what tells you which answer to use from the Excel. We're using left-tailed p-value here. So then we input the information, we get this answer. That's the answer we're looking at compared to alpha. So we're going to use 0.004, and alpha, our alpha that we're given is 0.1. Well, here we have that alpha, that the p-value is less than or equal to alpha. If you go back and look at the statements, when your p-value is less than or equal to alpha, you're going to choose to reject the null. So we're going to reject the null. And this is where you would then refer to the slides that shows you how you're going to state things as far as rejection. So it's the slide that says conclusion sentence chart. So you can go there, and then that will give you, so this is your third step. Your fourth step is stating it correctly. All right, so that is an overview of how to do these in Excel. So let's look here at the next example. The weight of a discarded plastic from a sample of 62 households yields a mean of 1.911 pounds and a standard deviation of 1.065 pounds. So we know this is a t-test in this case because we are given the sample mean and the sample standard deviation. We do not know the population standard deviation. So we're going to test the claims at the 0.01 significant level that the mean weight of discarded plastic from the population of households is greater than 1.8. So our sample is 62 households. Our sample mean is 1.911. Our sample standard deviation is 1.065. And our hypothesis mean is the one that says is greater than 1.8. So if you're asked for a test statistic, this is your test statistic. In your step 1, your null hypothesis is that your mean is equal to this mean here, 1.8. Your alternative hypothesis is that your mean is greater than 1.8. So in step 2, because you're doing greater than here, it is going to be right-tailed. So we're looking here in the Excel for the right-tailed p-value. So in step 3, that's what we're comparing to our significant level. So here we have 0.2075 is greater than 0.01. So we're going to fail to reject the null. And so then how you state that in step 4, you can go back and look at that chart for. I'm not going over that part extensively because I think on all of your homeworks, you don't have to write it out. You just have to choose between like 4 options. So it gives you like A, B, C, D. So we're just kind of skimming over that today. The last type is the one prop z-test. So this is when you're dealing with a proportion. So in a sample of 167 children selected randomly from one town, it is found that 37 of them suffer from asthma. At the 0.05 significant level, test the claim that the proportion of all children in the town who suffer from asthma is 11%. So the sample size that is given is 167. The sample proportion that is given is not explicitly stated here, right? Instead, we have to find it. So p hat is the sample proportion here, and it's saying that 37 out of 167 equals or have asthma. So we're going to just write in equals 37 divided by 167. When we do that, it fills in what our sample proportion is. So then it says, test the claim, the proportion of all children in the town who suffer from asthma is 11%. So that would be 0.11 as our hypothesis proportion. And so this is what we get here. So in your hypothesis testing, we know that we're saying the null hypothesis is that the proportion is, when it says is here, that means equal. So equal is always part of the null hypothesis. So we know alternative hypothesis this time is going to be the not equal. So for this case is equal to 0.11 or not equal to 0.11. So in 2, because of the not equal to right here, we are going to look at the two-tailed. So here you see it's extremely small. It's smaller than, it's going to round to 0. So in this case, we have 0.00 is less than or equal to 0.05. So we're going to reject the null. And again, you can look at how the statement sheet is to write your statement. So overall, that is how we do hypothesis testing. And again, when you use your Excel midterm, you have those 3 options: t-test, z-test, and one prop z-test. So you use z-test here when you are using, when you know your population standard deviation. You're using t-test when you don't know your population standard deviation for means, and you use one prop z-test anytime you're doing a proportion test. All right, so the last lesson, part of the lesson is over chapter 13, which is linear regression and correlation. So this is a very large formula for how to calculate R, which is our correlation coefficient. Nobody calculates R by hand. You will never see anybody calculate R by hand in the real world. So we, of course, will let Excel do that dirty work for us. What is important is for you to be able to determine what R is telling us. So R always falls between -1 and 1. So the closer we are to -1, our slope of our linear regression is going to be negative. So if you're getting -1, you have a slope that looks like this, which means it has a strong negative correlation. If you get close to 1, then it has a positive correlation. Now, if you get close to 0, then there's no correlation. So here, our R is 0.8. In this case, 0.8 is pretty close to 1, and we can draw a straight line that has a positive slope there. So this is positive correlation. Here, -0.8, you can draw a negative line that kind of falls through there, and it is a negative correlation. Now here you'll see when you're close to 0, you can't draw a line through either one of these, and so for C and D, there is no correlation. So linear regression comes directly from this idea of drawing lines through data, right? Data points, so that we can make estimations in the future. So this brief, we're going to use the formula for a line to be able to do this. To find the formula for the line, you need your intercept and your slope, which is given by your A and your B here. So we're going to walk through this. So in this case, we can look and we see that this has a positive correlation here. And so we would write y equals a plus bx here. So let's get a look. This one here is curved. So while it has positive correlation, it is not a linear correlation. So this goes over the slopes. So if B is greater than 0, you're going to have a positive slope, so a positive correlation. If B is equal to 0, you're going to have a horizontal slope, so no correlation. And if B is less than 0, you're going to have a negative slope, so you're going to have a negative correlation. So this is the generalized formula for if you were comparing multiple different things. So for example, let's say that your Y is your weight loss. Then each one of these is a different thing that could impact weight loss. So like X could be your water intake, X1, X2 could be how many calories you consume, X3 could be how much exercise you get, but all of those are correlated to how much weight you could lose. So that's the idea here, is correlating to a factor to an outcome, essentially. So here we would see that this has a positive correlation. So B is going to be positive. This E here is your error. So it's saying approximately how far away are these dots from my actual line? Like what is the error that's occurring here? Because our line's not going to hit every single dot. It might not even hit any of the dots. But if there's a correlation, it will flow through those data points. And the E is the error, or how far away from those data points we actually are. So this is another pictorial review of that idea of error. This is a pictorial review of how you find that error. So the whole idea is to be able to do linear regression, which is often used to make predictions. So we do this a lot. I do this a lot in my day job. So while I am your teacher, I also work full-time for the college as an administrator, as the assistant director of institutional research, and I do a lot of regression so that I can create models to try to retain students. So let's do this example. The chart shows the weight and highway fuel consumption for some mid-sized sedans. Use this information to answer the questions below. So we have our X, which is our weight, and then we have our Y, which is our gas mileage. So this is the weight of our vehicle. This is our gas mileage that our vehicle gets. And we're trying to see if the weight of the vehicle is correlated to the gas mileage. And if it is correlated linearly, we can use linear regression to develop a model. And then we can use that model to predict when a car weighs so much amount, how much gas mileage it should get. So let's walk through this step by step. Determine a linear function that could be used to model the data in the chart. Use 4 decimal places. So we're going to use Excel to do this for us. So I'm going to go back to this chapter 9 and 13 in class Excel here. So linear regression data. So this is the data that's in that table. I have already typed it for you in this example. So you're going to run this example with me. If you're following along in Excel. Now, with that being said, you would have to type this if you were just looking at this problem here. So even though I've already typed it for you, normally you would have to type that data in. Once you do that, you then have to walk through the steps. You're going to go to data. And if you click on data and you look here and you push the down button, you see there's a lot of different options, but what we can't see is this data option that I want right here. And so if you don't have that in your Excel, if your Excel doesn't have a data option right here, you're going to want to follow these steps. You're going to click down here and you're going to find more commands. And you're going to click on add-ins. And we want the analysis tool pack. So we're going to click go. We're going to highlight the analysis tool pack and click OK. Now you see we have a button here that says data analysis. So we're going to use this data analysis button to help us do regression. So I'm going to click data analysis here. And you know, it has a lot of different options here. We are going to use the linear regression option. So we're going to choose regression here and click OK. And now it wants us to input our data. So we're going to input our Y data by just highlighting. Then we're going to click here, input our X data by highlighting. I'm going to click labels because I did label my weight and my highway. If you didn't and you just had your numbers here, then you would leave labels unclicked. Okay. And then once I do all of that, I'm just going to click OK. And it will give me an output in a different sheet. Now this output is what gives us the answers to these problems here. So we want to know our A in this case. So if we go to our Excel output, we are given some information by these coefficients. Our A is what's called our intercept. So this is our A. So the A that you want is highlighted in yellow here. Our B is this coefficient here. So let's highlight that in green. So B is highlighted in green. So we can put in our A and B, and we're going to round to 4 decimal places. So 55.4386 and negative 0.0076 are the values we're using there. So again, that A value is 55.43856. Our B value is negative 0.0075. And so our Y comes from Y equals A plus BX. So I'm going to have 55.43856. It's plus, but we have a negative right here, so we're going to use minus 0.0075x. So this is now our model, and we're going to use this model to answer part C. Our model tells us, use your function to predict the highway mileage of a car weighing 4,500 pounds. So that's going to be our X in this formula. So we're going to do 55.43856 minus 0.0075 times this X of 4,500. Now you can do it in a calculator, you can do it by hand, or you can do it in Excel. In Excel, I would just type it here. I would do equals 55 point. You don't even have to do that. You can just highlight that cell because it's already there. Minus, or let's do plus here because this cell is already negative. And then you're going to do times that X that you're given. And you get 21.47. And so here we would say approximately 21 miles per gallon. And the part B is, what is the value of R? Well, that was given to us, even though we skipped that part. That is your R square here. That is the R that it's asking. Your multiple R is the R it's asking for. R square is a different value. So your multiple R is what is being asked for in part B. So it's 0.9869. So 0.9869 which means we have a strong positive correlation, because as the weight, this should be negative here. Excel is only going to give you positive answers for your R. Ours is negative because our slope is negative. So we're going to have a strong negative correlation, because as your X value goes up, your gas mileage goes down. So as the weight of your car gets greater, the gas mileage you get out of that car is less. And so this just shows you again how that is written. All right, so if you were using the Excel document for your midterm 2 Excel, I just put linear regression here, data. This is where you would type your data, and then you would use the analyze data tool and follow the steps we just went through. And so that is the conclusion of what we are